Good evening to everybody who's joined us here in Galway and to our viewers online. We're still climbing on 65, so there'll probably be a few more. This evening's event is being hosted jointly by the Western Division, our Western Region, and the Energy, Environment and Climate Action Group of Engineers Ireland. Today's team is focused on the marine operations aspects of offshore construction, and we've particularly asked for I experienced Master Mariner to join us this evening to share a mariner's point of view. We've heard a lot about the engineering, what the engineers do, what the scientists do. We don't hear very much of the key people who make that happen at sea. So this evening we're being joined by Shane Heverin. Shane is a Master Mariner of many years standing, and over the last 10 years has spent a huge amount of time specifically focused on offshore construction, everything from surveys to major crane operations to cable laying, and a wide range of both inshore and say shallow water and deep water construction. So he has a fantastic story to tell. The focus this evening will be on how vessels and how the Master Mariner fits into the big picture. It's very much, I would think of like it's like orchestra. It's like conducting an orchestra. There's so many moving parts on these vessels at sea doing these major construction jobs. So without further ado, I'll exit stage left and I call on Shane to take over. Thanks very much, Shane, and welcome this evening.
Thanks.
Thank you very much for joining us. Really appreciate it. So your camera straight in front.
Lovely stuff. Folks, you can bear with me for the next 30 minutes or so. I'll take you through a short journey. I won't be as eloquent as Dennis has said, but we'll do our best. I'm not a public speaker. I can talk away to a bar or a couple of interested parties, but I see the numbers up here and here it's a different story for me. They say that when you're talking to a crowd, that if you're a bit nervous, imagine people are naked and it makes it feel a bit better. With nearly 80 people now online, there's every chance that could be true. So I get that image out of my head. This working? We've got control here. There we go. So as Dennis said, I'm Shane Heverin, captain working offshore for a good few years now. I started my journey back in about 2002. Worked on a variety of vessels, including bulk carriers and tankers. 2007, I decided that I wanted to work offshore as a specialist niche area, utilizing a lot of specialized vessels that I'm positioning, lifting operations, subsea operations, and stuff like this. Master Mariner. So what is a Master Mariner? You'll see here it says unlimited. There are various grades of Master Mariner. I was fortunate enough over about 10 years to gain an unlimited certificate, which allows me to sail on any vessel anywhere in the world. I also have a BSc from NTI, and I'm a DPO, Dynamic Positioning Operator. So I'm qualified to operate the DP systems on board. Moved ashore in 2021, and in 2022, founded Cara Offshore with my business partner, Barry Ward. We'll talk about marine operations in the construction of offshore wind farms. We look at the role and expertise of the master. We look at the DP systems, and we'll talk a bit about the life cycle of an offshore wind farm. There are four main components. There's the survey and pre-approval, which leads up to the planning and consents. The big one is your offshore construction phase. In the bottom here, it says operations and maintenance. So your O&M, which will carry on for about 20 years, give or take, hopefully give. And the decommissioning phase, which at the moment is more or less in its infancy, because this is relatively new technology. Right, the role and expertise of the master. What is a captain in the offshore setting, or any setting for that matter? Master Mariner is somebody who's attained a Master Mariner certificate of competency. Usually takes a minimum of 10 years. Captain is a master with command of the vessel. Generally, you'd hope to have somebody with extensive ship handling experience, especially in the sector that you're working, and he'll usually be a DPO, a Dynamic Positioning Operator. And we'll talk about DP systems in a minute, because it's really core to how the whole operation works. The master will coordinate with the OCM, that's the Offshore Construction Manager, the client reps, and any other third parties to effectively execute the project requirements, so to deliver what's expected. There are many departments on a ship. So the master will always come from a deck department. You start off with a cadet, third mate, second mate, chief officer, eventually captain. You work with the chief engineer. You have an engineering department with ratings and officers there. Third engineer, second engineer, chief engineer. You'll have hotel and catering staff. You have a chief steward or chief cook there. You have a survey crew. You're not headed up by chief surveyor. So you can see where this is going. And a project crew. Don't need chiefs really, but they're a bit left out. The photograph here, you can see actually my fancy bottle for Mark. The photograph here is on a vessel I was on recently. And it demonstrates 3 different departments working together. On the very left of the screen, can you see the cursor? Yeah, on the left of the screen is your survey department with many more screens, but the phone could only capture so much. In the middle is your ROV department. This was on a rock dumping vessel, a flexible fall pipe vessel in the last couple of weeks. And then you've got your project team here, headed up by the shift superintendent, shift supervisor. And the next photo will demonstrate your dynamic positioning station. So your DPO, your dynamic positioning operator sits here. With a second one, it's like in an airline, you need 2 DPOs on the desk at all times, or available in the vicinity of the desk, one normally operating, and after an hour to change out to ensure there's no fatigue, to monitor one another and make sure everything is running smoothly. That photograph will kind of demonstrate, as Dennis mentioned, how everything needs to be pulled in together and operate as a cohesive unit. All right, dynamic positioning. So there are many types of vessels working offshore, and most of them are going to be dynamically positioned. It's a bit of a mouthful. So we'll talk about that system in its entirety itself, because that's key to how everything else functions. But there's a selection of different DP vessels. There's crane vessels, there's walk-to-work vessels, and subsea support vessels. I should say this photograph or this presentation, we've worked on all the vessels that I've used on this, but the photographs are taken from the internet because I need to be careful about what I'm sharing from our own work. There's proprietary images and technology and stuff like that. What is dynamic positioning? The Nautical Institute defined it as a vessel capability provided by an integration of variety of individual systems and functions. So in layman's terms, and how I describe it, it's a system for maintaining position of the vessel or vessels and maneuvering them without the use of anchors or tugs. You can use anchors in relatively shallow water. Once it starts getting deeper, you're really running into constraints there. And it could be argued that without DP, you don't get these major offshore projects, especially in deeper water. It's just not feasible. So we'll talk about that now. The DP system will take the vessel known where it needs to be by a variety of systems, by lasers, hydroacoustic sensors, microwave-based technology such as radars, taut wires, which is slightly older technology but is still in use, knows where it wants to be, and then it knows where it actually is, and by measuring the difference in applied thrust to various thrusters on the ship to maintain its position and heading. Or it may also follow a target. You can see there's a little ROV there. So as that moves, you can have your vessel set up and follow that along a certain track. Or you can tell it, you put a route in and you want the vessel to follow that track at a certain speed and to change its heading. But all this is monitored by your DPOs at all times. There are certain forces acting on the vessel, 3 of which we can control and 3 we can't, but we need to know what they're doing. So the main forces will be surge, sway, and yaw, which can be controlled by the vessel by using the thrusters. The other things we need to know are your pitch, roll, and heave. That applies more to lifting operations when there's a crane, because as you can imagine, on a large crane, a couple of degrees of roll when it's swung over the side is quite an arc that's described by that. The system itself allows for 100% redundancy should anything go wrong. It's usually split into at least 2 main engines, 2 switchboards, and redundancy right down the line in thrusters, control stations, and so on and so forth. As I said, you've got the references feeding in, so they'd be radar-based, such as Radiscan or Radius. You'll use a laser-based system perhaps, where you shine a beam on a reflector on an installation nearby, and that'll measure range of bearing. You can use your subsea systems, like your HIPAP or hydroacoustic systems, on a USBL, which is an ultra short baseline, or various baselines, depends on the angle that's in use, through a transponder that's protrudes through the hull. You can use taut wire, which again, pump weight on the bottom with a wire to the vessel, and as the vessel moves, it'll measure the angle at the head of the taut wire. And of course, it's good old, well, these days it's nearly old-fashioned GPS. Although there's a differential correction applied to the GPS, you'll normally have 2, maybe 3 units working, and the vessel compares all these measurements and will really refine the position it's expected to be in. As I said, the sensors then will measure the wind through anemometers, 2 or 3 anemometers, because we need our redundancy in case one goes down. Gyros, again, you'll have maybe 3 gyro compasses, your MRUs, which are motion reference unit, and various inertial systems. The position keeping, which is half covered, I see, we talked through it. You've got your main engines, at least 2. You have 3, 4, 6, 8, 12, depending on what you're on. They can be straight coupled to propellers, or they can be coupled back to shaft generators. They will go to at least 2 switchboards, but again, you may have 3, 4 switchboards depending on the configuration. And then switchboards then will supply power to the various components, such as tunnel thrusters, retractable thrusters, azimuth thrusters, and all the other thrusters you can think of. So I wanted to talk about that because that DP really is core on how everything else is going to work. Without the DP, it really cannot be emphasized enough how difficult these projects would be. You can be operating in close proximity, say it publicly maybe, but I've had to back ships in underneath rigs as opposed to keeping 20 meters off them or so, but you back to back the ship underneath a rig with a leg either side so you can conduct some in operations there. Not ideal, but sometimes these things had to be done. Obviously, these days things are much safer. When you start with the wind farm, the developer decides where they want to work. They need to conduct a range of surveys so they can, as you know, as engineers, look at the data and decide where they're putting it, file for consents, various things like that. You got your geophysical surveys, side scan, sonar, multi-beams, you've got sub-bottom profiling, marine magnetometry. And I just realized that I've lost all my notes on the bottom of this now because I've never used Zoom before. So we're going to have to wing it, folks. Sorry about that. You'll do route and UXO surveys as well. So route surveys will be for cables and the lights coming in. And UXO, for those that aren't familiar with it, is unexploded ordnance. You might have sea mines or unexploded bombs from previous wars and stuff like that. Ecological surveys, looking at fish stocks, marine mammal studies, bird life, all that. And once it's near the shore, you have to operate off a vessel. So the range of vessels really varies from quite small, maybe 15, 20 meter vessels, right up to something that could be 300 or 400 meters long. Marine Institute aren't getting good advertising here tonight. So the top vessel is the vessel that we had on charter ourselves. On the aft end of it, you'll see a LiDAR buoy. That buoy belongs to Green Rebel Marine in Cork. IDS monitoring at the time when we did it. That vessel was chartered to deploy the buoy in a potential offshore installation in the North Sea. It's fairly indicative of the smaller vessels that you might use for your geotechnical surveys. And your geotechnical surveys, then, as we see there, lab samples, CPT, core samples, basically the nature of the seabed, how solid it is, and especially what's underneath to take the foundations of these huge structures. And there are a lot of weights at play here. Okay, foundation installation. You figure out the seabed. You figure out how you need to anchor your foundation. Next thing is to go and do it. Different ways of fixing your installation to the seabed. So for shallow water, up to maybe 60 meters, you go fix bottom. You just drive it into the seabed either with piles, or you can use a suction caisson section, which we did in Seagreen, suction caisson bucket. That's effectively just, you sit your can upside down in the seabed, you suck the water out with pumps, and they'll pull themselves into the seabed. Deeper water, beyond kind of 60 meters out, you're looking at floating systems, such as spars or semi-subs, and they'll be deployed with more old-fashioned technology. I say that very considerably because the technology might be older, but it's coming from oil and gas background to more semi-submersibles and the likes of that. So it's still fairly cutting edge technology. I mean, the amount of designing that goes into just a step per your Bruce anchor is amazing. You know, and you're using your physics, the rest of it for your suction or your torpedoes. Torpedo anchor could be 100, 120 meters in weight, 60, 70 meters long, and you launch it into the seabed a couple hundred meters height, and it'll bury itself down, put a few of them in, nothing is going anywhere after that. So you can see Green Foundation. Sea Green is, I believe, still the deepest fixed bottom offshore wind farm in the world. And that has kept us very busy this last couple of years. So I'm going to kind of use Sea Green for the reference for most of this talk here. In the photograph, you can see the size of them foundation jackets sailing out of the River Tay. The barge itself is quite big, it's very big. But compared to them two jackets on it, they're massive. You can see a line along here. That line is a target line. Depending on the foundation, each foundation jacket is made specifically for a certain area of that wind farm. And the caissons will differ in height based on the depth of water and the nature of the seabed. Fairly big, as I said, you know, big weights there. These ones were in and around 2,700 tons. They were a suction caisson design. That line I indicated to you a second ago is about 10 meters, but plus or minus, depending on the seabed. That's where your target burial is. So you launch that over the side. Not that simple. You can see the size of the jacket there compared to the crane next to it. The idea is you lift up your jacket, remove the barge, and you'll install that on the seabed, just lower down the crane. But a couple of points to consider there is, number one, the position. Are you in the right location? Number two, it's the second you take the weight of that jacket on the crane, that center of gravity, which is in around 2,700 tons, goes right to the top of the crane. It's gone right up there to where the cables come in. So that's a massive shift in the center of gravity of the weight. That needs to be considered with ballast, and communication is going on at all times in the background. This is happening between your dynamic positioning operators, your ballast operators, your crane operator. Not as eloquent as Dennis said, but it is really well orchestrated nevertheless. Communication is key, and that really can't be emphasized enough. Next stage then is, and doesn't have to be, but it's easier if you, in our experience when it's done this way, is your WTG, which is your wind turbine jacket. That's the tower, nacelle and blade assembly. And on Sea Green, they were being loaded out on Wind Orca. This vessel, but of a different name, she was since bought and renamed. We bring out 5 of them towers, 5 nacelles and 15 blades to assemble. As I said, my notes are gone. They're in there somewhere, I can't get to them. But again, they're fairly big, substantial units. I think the maximum height of them towers when fully erected are about 206 meters from surface of, from sea level to the tip of the blade. I can't remember the swept area, but they're up 10 megawatt design. 16 megawatt, which is about 206 meters area, or sorry, 206 meters diameter. This is a swept area of, off the top of my head, 50,000 square meters. So each of these are large, very large installations. That can't be underestimated, and it's very hard to do so until you get out there and do it. The main things there, again, you're lifting operations, but for the master and the crew on that vessel, one of the key considerations when they're jacking up is right when they wind the legs down and they're touching the seabed, they start to take the weight of the vessel on the legs. You need to look after or be cognizant of what's known as Swiss cheesing or punch through of the legs going through the hard pan or the surface of the seabed, punching through to softer seabed beneath that. Cable installation. No point in having wind turbines and offshore substations and the likes if there's no way to get the juice from them or the sparks. So there's a couple of different types of vessels. I've just taken 2 examples there. The first one is a new vessel ordered by Jan de Nul. the brighter red one with the yellow on it, and the other is Seaway Amory. That one, the smaller one, is still so small, which is about 100 meters in length. Give or take, I think she might be 105. I can't remember off the top of my head. In this photograph, you'll see the ROV swung out, the side ready for deployment. That vessel will actually have 2 of these carousels that I mentioned here. So each of these carousels is loading up the cable and transporting it on site. This vessel here has 2 of them underneath. It's actually very nice design, the way it's laid out. Everyone is protected on deck when they're working. So for the people involved in the design of ships, these are some considerations to bear in mind. Again, there's a lot going on in the background here between your shift supervisors laying the cable. That duration, or the rate of lay basically is quite important. Layback, make sure you're not kinking cables. So your DPO, your shift supervisor, and your ROV pilots, all these teams need to be talking to each other. Engineers need to be making sure the vessel is up to scratch and doing what she's supposed to do. You've got your catering staff making sure everyone is fed 24/7, because these shifts, 12-hour shifts on and off, they run round the clock. The cables themselves, you could have up to, top of my head, the last project we loaded out cables for was on the east coast of the US. Then we put about 200 kilometers of cables on in one load. And them cables, depending on the type, could be up to 100 kilos per meter. You could have a bundle going on, fiber optic cables and the likes going through. So they're fairly, from your point of view, I guess, the engineering even of these cables is quite interesting, how they're constructed, the armoring, all the tests that's done. It's over my head. I'm not as smart as you guys, but I'm going to do the job. The cables need to be trenched in. So here I have just 2 units there. The yellow one is a tracked trencher, so that straddles the cable. I did have a little video animation showing how it works, but it's not working on the system here. And the white one is just it's an ROV that are used. And the reason I stuck these in, from a master's point of view, it's ROV pilots drive these, not the ship's officers. But very, very important for offshore work of any type, whether it's oil and gas, offshore wind, research, whatever's going on, for surveying the seabed with a wide variety of equipment, for grouting. And that's something I left out earlier because my notes are gone. After the jacket is installed, there's a gap of several meters remaining inside that suction caisson. That's filled with grout. The grout is designed as Portland cement with some additives, so it doesn't go rock hard. Idea is there's a lot of harmonics at play with these wind turbines. They're very tall, slender designs, and the resonant frequency of the jackets and towers themselves, it needs to be engineered out so you don't get these vibrations. Nevertheless, that engineering goes so far as to make sure that that Portland cement never sits hard, but is like a good hard jelly, I guess. And there's probably a better name than that. Somebody who's more articulate will come up with it later. But your ROV will be key on that. So your ROV will be used for monitoring touchdown points of cables. It's looking where the jackets, when they're putting the seabed and you're sucking out your suction caisson, it's monitoring what's going on there, checking for leaks around, and make sure there's no water being sucked back into it. They'll be used for, as I said, the grouting operations, rock dumping operations. They're indispensable, and the ROVs will do the jobs you don't want divers doing. So in this day and age, you're trying to make these projects as diverless as possible. It doesn't always work, but that's the plan. You do need personnel in the background ready to go, but I have to include dive support vessels in this presentation because the move is away from them and it's only on specific tasks they're brought in. The trencher itself, in this one, the yellow one, is it'll sit over the cable. It's got cutting swords. Either side are high pressure cutting swords that go down each side of the cable. The last job we did, we were burying cables down to 3 meters with these systems. Obviously, it depends on the nature of the seabed. Hard going, you need mechanical trenchers with either wheels or chains. As I said, the video doesn't work, so we'll continue. Cables and the installations, these assets, they need further protection from the environment, from fishing activities such as static gear or lines or whatever might get caught up in them. Rogue vessels that might drift off in the night and decide they're going to drop an anchor without paying any heed of where they are, or just, you know, erosion. So you install scour protection around them and rock armoring. That's a flexible fall pipe vessel. That one there only came off about 10 days ago or 2 weeks ago. You load up about 26,000 tons of rock and stone of carefully graded aggregate, and you can very precisely place that rock over your cables or working in around the bottoms of the jackets. Again, just to prevent that scour erosion. But they're very specifically designed, and it's amazing how accurately you can install that rock. So you can install, you know, load up 26,500 tons and put it almost exactly where you want it every time. Just while I talk about that, one of the key things that the master is doing and his crew is looking at the weather. Because obviously if you've bad weather coming through, that vessel is going to be much harder to control. You need to be cognizant of how you're approaching the platform. If you have a blackout of the vessel, which hopefully is designed that it won't black out, but in the worst case scenario, if something goes wrong, you really want to be setting up and doing your tests away from everything, so that you're fully running and tested and confident that you can approach that installation to carry out the task at hand. That bottom is gone. Can I move this?
Yeah. Maybe shrink it, drag it right up to the top.
There we go. Out away from
the right more, I'd say, if you can. Good man. Just slip it away over.
Oh, that'll do. So thanks, Dennis. The bottom of that here, that's an ROV that fits over the fall pipe. Fall pipe comes out in sections. This vessel has deployed rock up to about 14,000 meters. So they're quite versatile and they're quite efficient at what to do. You set up your ROV, it's maybe 8 meters, 6 or 8 meters above the seabed. And you can position that fall pipe laterally over the pipe or the cable in this case to make sure it's adequately buried. And you'll survey again before and after. So you'll do a pre-installation survey and a post-installation survey. Compare what you've done to what you're supposed to have done and carry out any remedial works before you move on to the next stage. Other scopes, then, less glamorous stuff, I suppose. You've got your infield support. So that would be anchor handlers and tugs, platform supply vessels, and the likes of these. So they'll carry out some pre-leg grapnel runs to make sure that there's nothing to obstruct cables and pipelines on the seabed, or cables in this case, on the seabed before they're installed. So you literally run along with a grapnel hook, drag it along the seabed, and if there's any gear in the way, you should be able to remove it that way. Boulder removal is a thing. It's a massive big grab. Again, it goes back to the ROV, linking up your dynamic position operators on the bridge. If there's any rocks in the way of the surveyed route, the grab goes down, huge mechanical hand, picks it up and puts it on the base of the ship. Now this will be done with an actively heave compensated crane. So as the vessel moves, the crane itself hopefully will keep a somewhat stable position as it's lifting this up. Another support services needed on field or in the field would be accommodation. Any of these projects, you could have up to 1,000 people, 1,500 people working offshore at any one time, which is hard to fathom. But some of these vessels, you could have 500, 600, 700 people on them, on the large construction vessels, such as the Saipem 7000, which I showed you lifting the jacket off. And they require support. They require very often supplies coming out with either CTVs or other platform supply vessels and the likes. The barges, which I showed you carrying the jackets, will be handled by anchor handlers, brought in alongside. Normally, you have one tug towing the barge, and another tug then assisting to bring it back alongside the actual crane, so they can lift it off and install it on the seabed. And more general anchor handling services infield. Anchor handling is fancy tug, lots of winches, you have shark jaws and carm forks on the stern and rollers, so you can lift stuff on and off over the stern quite easily. These days, most of them would have a crane, although not all of them. And then closer to shore, which is really less glamorous because it's the smaller vessels again, but actually very, very interesting work, good fun when you're at it. You have to repeat basically what you're doing offshore. You need to get that cable ashore. So again, you're back to your surveys. With smaller, more shallow draft vessels, And it makes it quite challenging because as you're closer to the shore, you have shallower water, your propellers are less efficient, you have less power available overall because they're small vessels, often higher, faster currents. You have the challenges of where you're putting people. So you might have multiple vessels working very closely together, deploying trenchers and ROVs, as well as providing accommodation and food and everything else for the divers, pillows because they like to cry themselves asleep at night sometimes. And again, your surveys, everything else that we spoke about on a smaller scale. But that's kind of more or less the construction phase. Hopefully, these things will be in operation for at least 20 years. Some of them, you know, they're planning up to 30 years at this stage. You might have more insights than I do on this, but to my experience, to my knowledge, 25, 30 years is a feasible lifespan for these. I don't know if John O'Regan from ORT is ever going to see what we're talking about here, but John is planning on building some of these vessels. This is a construction support vessel or service offshore vessel here. Is what they call it. I forget now, actually. The blank on it. That's a walk-to-work vessel. People, the technicians will stay on that for up to 2 weeks at a time. They stay on the field. They walk to work, literally, over and back here. So this will tie in with the dynamic positioning system, and they can measure the angle or the azimuth of this, and they can measure the length of it as the vessel moves in the water, and that'll feed back in with the other sensors to tell the vessel where it is in relation to where it should be. And on the aft end of that, you can see these yellow bars, which are the bars for your, that's your boat landing, where a crew transfer vessel can push up against and people can embark and disembark. Because you could have maybe 80, 90 people, like technicians, as well as the marine crew living on here. You don't need 80 or 90 people on your jacket. What they'll do is they'll put a few guys or ladies up here, and then using the crew transfer vessels or daughter craft, they can deploy others around the field and then pick them up later on. So the daughter craft could be like this here, although this is a crew transfer vessel. This one is operated by Farrer Marine, based in the East Coast, another Irish company. We're trying to plug them all tonight. They're characterized by their high speeds, usually 24, 26 meters in length. They'll do maybe 30 knots. They're a very fine hull design, but that hull design has some limitations. One of it being the amount of cargo they can carry. Current legislation will restrict them to 24 passengers, in Ireland, and therefore it's 12. But they're also restricted with how far from land they can operate. You know, eventually becomes unfeasible to transport people for 2 or 3 hours in these things. Most of the technicians on these aren't seafarers. They're quite happy to remain on shore where everything is nice and solid. So they can be as green as that vessel when they get out in sight, and trying to knock a bit of work out of people who are that green and would rather be anywhere else is it's hard done. I mean, I was seasick, thankfully only the once. Honest to God, if I saw lights offshore that night, I'd have started swimming. Nothing was keeping me on that ship. Thankfully, I got over it, about 20 years done since, but it always stays with me. And I sailed with one guy. He was 16 years working in the North Sea. He was working 4 weeks on, 4 weeks off. About a week, the first week of every 4 weeks, he was sick. How he did this for 16 years is beyond me. But horses for courses, I guess. During the life cycle of the wind farms, you know, the previous 2 vessels are kind of what's happening topside. The technicians going on looking at, you know, the material protection of the jackets. They'll be looking at the workings and the gubbins going on inside the turbine. You can fill me in with all the technical details there. I don't know them. I don't need to know them, honestly. I just need to get them out there and concentrate on that side of things. But they require quite a bit of maintenance. Subsea, we're talking my language. You're back to your larger vessels. Again, that's what is dynamically positioned. So you've got your DPOs, a typical crew on a DP bridge will be probably 6, 7 people. So you have the captain, you might have 2 chief officers or chief and a first officer, and then you may have either 2 or 4 DPOs, second mates, operating with them, as well as your marine crew on your deck department. So they're quite busy. These will come in, they inspect the cables on the sea wedge and come into the jackets and stuff like that. And You'll have ROVs and the capability to carry out repairs on these cables if needed and conduct routine maintenance and stuff like that. Again, large active heat compensated cranes. You could have over 100 technicians on PAX, by the way, for anyone that mightn't be sure. PAX is just short for passengers. And an ROV, whilst we're at it, is remote operated vehicle. I'm sure everyone's familiar with them, but just in case, shouldn't make assumptions. Where are we? Right, that's the O&M phase finished. So there's really 3 types at play there. You'll have some other smaller ones involved as well. These are the most ones you'll see. Decommissioning. Honestly, I haven't much to say on this because we're more interested in building things at the moment. Very few are near the end of life, although there are a couple at this stage scattered here and there. So people need to start thinking about that now. One of the big things is vessel availability. Decommissioning is going to be more or less a reversal of the installation. The problem is you have very limited vessels and they're all more or less tied up for years in advance. One I was on recently, she's booked up for the next 7 years, sorry. So by the time you get vessels available for decommissioning, I'm not sure how that's going to go. Will they build specialist vessels or will they just reuse the same vessels that they build them with? I can't answer that at the moment. So, because there's no specific decommissioning vessels built for wind farms, I've used one for an offshore oil and gas situation. That vessel is nearly 400 meters long. It's about 200 meters wide, give or take. I don't have the specs off the top of my head, but that'll park in a rounded jacket. So the yellow jackets I showed you earlier on an oil rig is similar, or an oil platform. Literally parks either side of it, clamps on, cuts the jacket, and just takes it away. Off she goes. Honestly, I don't want to be filling up with nonsense. This technology for offshore wind farms is not, I don't think, in my opinion, too well thought of at the moment because, as we said, we want to keep putting them up. That's more important just yet. However, at the end of life, consideration will be given to when they're being removed, whether they're going to leave artificial reefs intact in the way of the rock berms, or are they going to remove, leave parts of the jackets? There's arguments for and against. I mean, the reef systems provide fantastic refuge for marine life, but I guess if you're a fisherman or fisherwoman, you're not going to appreciate these things stuck in the seabed tangling nets. So that's going to be another bit of politics down the line. So in conclusion, right, we've seen there's various sizes of vessels and functions. One of the functions really the key function is dynamic positioning. That's the key part that holds it together. I mean, there's a lot of other things going on, but from my point of view, no matter whether you're doing jack-up operations or you're doing semi-submersible operations, such as the crane vessel I showed you, or you're doing a cable lay, it all comes back to dynamic positioning. The vessel is a platform to do the job. The captain is a driver, working with his crew, working with the clients to carry out the job. DP is still only another tool, but it's quite an important one. I have a habit of building wind farms where there's wind and bad weather, and that makes the job quite challenging. The same things that make them good environments for wind farms make them terrible environments to work. Nevertheless, they're built year round now. They don't stop. North Sea, they're still going. It slows down in winter. It makes presents further challenges and creates delays. But everyone uses their best endeavor to go on and use a bit of common sense and your industry practices and guidelines to get there. You're using a lot of innovative technology, no doubt about it. Even the cranes themselves are very high tech. Dynamic positioning, as I keep going on about, your ROVs and your trenchers, they're being designed and refined and redesigned on a weekly basis, probably. I work for companies that we started off with one trencher and it works fine, but there's better ways of doing it. By the time you're finished, you have a completely new trencher built, ready to be tested on the next project. The loads are enormous. Loads are, we talked about jackets for the turbines themselves, but they're even larger for the offshore substations. It could be maybe 4,000, 5,000, 6,000 tons. And again, that's 4,000, 5,000, 6,000 tons. When that's sitting on a deck, that's one headache. And that can take its own consideration. The second you lift it off, that weight is gone to the top of the crane. And when you consider the height of that crane as a massive lever there that needs to be borne in mind when you're shifting ballast and you're trying to keep everything upright, because when a vessel doesn't stay upright, it's a lot of paperwork. Of course, relatively large passenger capacity. When I say passengers, I mean technicians, because there are distinctions between what's known as a special purpose ship, which gets one set of regulations, and a passenger vessel, which is a separate set of regulations. So there are distinctions there. So whilst I reference passengers, technically I'm referring to technicians or industrial personnel, which is a separate category.